Northwest 152, runway 16 left, clear for takeoff.
Clear for takeoff, Northwest 152.
Resident 32, South Tower, 6 left, taxi position at home.
Positional 16 left, Resident 32.
Alaska 157, contact departure. 157.
17, 18, turn to final 46.
Advanced navigation technologies and improved operational procedures developed to serve CNS ATM and GATM objectives will improve flight safety and economics in air transport. To use these advanced navigation procedures, aircraft must be qualified to perform within required navigation performance standards. RNP standards require an aircraft be capable of navigating within a defined space along its flight path with accuracy and reliability. The safety and economic benefits of RNP navigation are available now with advanced airborne flight management technology. The flight management system from Smiths Industries is RNP approved and ready for implementation today.
Right now, we basically hand carry these airplanes through the systems with radar vectors or with similar techniques, and in the future we have to find ways to make that process more efficient, because right now much of the difficulty occurs because we're separating regions of airspace from regions of airspace, whether or not there are other aircraft there. It's important that we achieve our CNS and ATM objectives for the long term, and we have to progress from the current system that we have now to the future system. And our NP for navigation, our CP for communication, and our MP for monitoring are all important components of setting that infrastructure to match together smart airplanes with smart ground systems. So for the RNP part, we have to find a way to implement that in terms of procedures for arrivals, for departures, for instrument approaches, for missed approaches, and then to use it to combine with conflict probe systems on the ground to make sure that we can efficiently separate airplanes from airplanes and not just portions of airspace from portions of airspace. And RNP will help us do that by having a good understanding of where an airplane's projected flight path will be. But it will be a continuing evolution, and some of the, for example, RNP-based arrival and departure and approach procedures are being implemented as we speak. Some are already implemented, and a significant more will come online in the next 3 to 5 years as we move toward an ICAO international standard.
Alaska Airline is the first airline to develop and implement RNP procedures using Smiths Industries flight management system.
The initial project that we undertook was at the Juneau Airport, trying to create an approach that flew down the Gastineau Channel to land in a westerly direction on runway 26 at Juneau. Juneau does not lend itself to conventional type nav aids very well because of the terrain. The valleys that you're actually able to fly through are not aligned with the runway. And consequently, you can't line up an ILS facility, for example, a localizer and a glide slope, with the Gastineau Channel, because one, there's not enough room in the channel for the normal lateral obstacle clearance that one would need to meet. But secondly, to align those up with the runway, basically you'd have to fly through terrain to get to that point. The terrain geometry around Juneau is just not practical for ground-based navigation aids to be used. The reason that we selected Juneau first primarily was because that if you could do what we wanted to do at Juneau, you could do it anywhere. So hence we picked the toughest case to start with, or the toughest application, with the idea that success there meant success virtually at any kind of airport that we operate into today. And we had to be convinced that our envisioned application was in fact certifiable, approvable by the FAA, and would be willingly flown by our line pilots. When you consider what the alternatives are in Southeast Alaska and that operating environment with its relatively limited nav aids, lack of radar coverage, and the weather in combination, the dual FMC installation and being able to fly these RNP approaches in LNAV and VNAV with flight guidance right to the runway is a very, very compelling safety argument. And it's one that our line pilots gravitated to very quickly and very naturally. In the case of what we were trying to achieve with RNP, we were providing a very, very good alternative in that we had very, very precise flight guidance Now not just to a point 2 or 3 miles from the end of the runway, but in fact right to the runway threshold, and it allowed us to incorporate the use of autopilot into our procedures, where before we would have had to been hand flying at the same time we're looking outside, maneuvering visually, configuring, running checklists, and those types of things. Consequently, I think the FAA recognized it as being a substantial safety improvement. Once you understand the application of this technology, it's a very intuitive link to see the implications for safety and the great safety benefits that there are associated with it.
When Alaska Airlines was developing Project Juno, they had a number of technological capabilities at their disposal, but what they didn't have was an integration process. They needed this flight management computer to take and host these particular sensors and create a navigational path for the airplane out of this information. And this is what Smiths has been able to do with their advanced navigation software that they've developed.
The flight management system, as it is configured for Alaska Airlines, is composed of 2 flight management computers, 2 GPS receivers, and 2 FMC CDUs, or control display units. There are also dual inertial reference systems on board that, together with the GPS receivers, nav radios, the air data system, and the engine fuel system, feed data to the flight management computer. The FMC integrates the data to generate the navigation track and guidance commands to fly an RNP procedure.
The Juneau area, both from a geographic standpoint and from the standpoint of its climate, are very interesting and a very challenging area to fly in. There are mountains that rise up to over 5,000 feet within a mile of the runway threshold, at both ends of the runway, in fact. It's a very beautiful area. It attracts many, many tourists from both cruise ships as well as air travelers through the Juneau area during the summertime because it is so pretty. However, you take that area in the winter and you combine high winds, snow, limited visibility, fog, a coastal marine type climate, throw in the presence of a glacier or two here or there, and you have a microclimate that creates a widely varying set of weather conditions. Consequently, that can make for many, many days where you have, in the old days of flying, where you just can't get in there under the old type of instrument approach procedure. So you're essentially at 1,000 feet above the airport, 3 miles from the runway, when you must decide whether or not you can continue the approach. With our new technology, with the dual FMC installation and flying an RNP approach procedure, we are now down to minimums of 337 feet and 1 mile visibility. And with other enhancements to the local airport, namely an approach light system, we'll be able to take that down to a half a mile of visibility and 337 feet, possibly even slightly lower. Consequently, you can see the vast improvement that's available to our flight crews and, more importantly, to the people that are paying passengers to get on our airplane who want to get to their destination. With the new procedure, it's vastly simplified. Keep in mind, you flew to that airport using LNAV and VNAV guidance already. You have very accurate displays. You know that the airplane can navigate itself very, very accurately and with great precision. You get flight guidance right down to the runway threshold, so you can literally follow your flight director, or you can even leave the autopilot coupled and hooked up if you want to. You get the airplane configured earlier, your landing checklist is completed earlier, and it basically takes what would be a very dynamic, non-precision approach and turns it into something that's virtually identical to an ILS, which means everything is basically done 5 to 7 miles from the runway, and the rest of the time you can concentrate solely on flying.
The flight management system is really the heart and soul of the RNP process. It takes all of the navigational inputs and uses them to establish a track for the aircraft. And when we got the GPS sensor, it brought in a new element of navigation. So the GPS then allowed us to create these procedures and these plots that allow us the required navigation performance capability we are now seeing in Juneau.
The approach to Juneau 26 is from the southeast along the Gastineau Channel. Mountains on both sides of the channel create shadowing for ILS signals and prevent their use. Previously, runway 26 at Juneau was available only under VFR conditions. Now, even under adverse weather conditions, Alaska Airlines can approach runway 26 and maintain the required navigation performance of 0.15 nautical miles required by this approach, flying on autopilot if the pilot chooses, down to 50 feet above the runway. Situational awareness is greatly enhanced because of the lateral and vertical positioning information provided by GPS and the integration with the latest and enhanced ground proximity warning system technology.
The beauty of this operation using dual FMCs in an RNP approach environment is that you may now leave your cockpit displays in what's referred to as the map mode. So the display of the electronic horizontal situation indicator allows you to continue to look at your magenta track line and all the waypoints that are strung out along that track line. What's on your map display on the cockpit panel is exactly the same as what's on your instrument chart display that's clipped onto your control yoke. So you have an electronic display of what's on your chart, and you know basically exactly where the airplane is positioned as it moves along that chart.
One of the main concerns of an operator is controlled flight into terrain, or what we call smithvid. This particular system has the ability to reduce the exposure to smithvid because of its geometric path and three-dimensional flight capability and guiding the pilot in a much more stable approach to a runway.
You know that you can navigate the airplane very precisely with RNP, and because you know that, and because you can construct a customized ground track in and around topographical features, you can navigate, in essence, thread the needle through terrain that before this type of technology arrived you could not do.
The one thing that the Smith's flight management computer brings is that it doesn't matter whether you're an airline or whether you're a package carrier or whether you're the military. It brings an element of sophisticated navigation performance that's going to fit the new radio navigation plan and CNS ATM, and for the military GATM.
Economics is also a prime concern of any air transport organization. The FMS from Smith's Industries has been shown to provide a swift return on investment. Prior to RNP approval for runway 26, northbound flights to Juneau were required to use runway 8 when VFR conditions did not exist. This meant flying to the west and coming about for the approach. The RNP approach to runway 26 has permitted Alaska Airlines to eliminate the need to depend solely on runway 8 for access to Juneau during instrument meteorological conditions, and it shortened flight time by 15 minutes on its daily routes from Seattle. This saves about 600 pounds of fuel on these flights. For Alaska Airlines, the potential savings in fuel costs because of RNP capability proved to be an early economic benefit of Smith's Industries flight management system.
Smith's Industry offers a cost-benefit analysis tool. It's been developed by Smith's. It's a specific math model that helps the airlines understand what their investment requirements are, how to purchase the right equipment to configure their airplanes to use in their route system. It comes at no cost to the airline. It's something that we offer as a service to the airline.
With its advanced navigation capabilities and RNP capability, Smith's Industries flight management system has proven to provide air transport operations with improved safety and economics. Smith's Industries flight management system is designed to support the plan for growth and implementation of the worldwide CNS, ATM, and GATM systems. The technology to provide the safety and economic benefits of improved navigational procedures is available now from Smith's Industries.